Okay, good morning, good afternoon, good day, whatever it is. Here we go. So I'm going to follow up with the factoring that some of us didn't get to yesterday. Remember, you can fast forward and slow down this, and I'm going to go through it pretty quickly because there's a lot of stuff to do and there's a convocation today, so we have shortened class periods. All right, so I am looking at where we left off yesterday in our factoring review. I'm going to start with number 5, and I'm going to go through the same process that we had talked about. So first of all, I need to look for a greatest common factor. And I see there is a 1 here, a 5, and 24. Because 1 is my smallest coefficient, 1 is a factor of everything, but that does not help in factoring out anything. So, no greatest common factor. This is 3 terms, so next I am going to use Xbox. When I use Xbox, I have to look for my A value, which is 1, my B value, which is -5, and my C value, which is -24. Up at the top of the X all the time is A, first term times your last term. And I should say we're only talking about the number. So 1 times -24 is -24. B goes on the bottom, and B is -5. So I'm looking for 2 factors that multiply to give 24 and add to give -5. Multiply to give -24, add to give -5. So I think of all my factors of 24. And I'm telling you, just write them down. Don't keep it all in your head. So that's 1 and 24, 2 and 12, 3 and 8, 4 and 6. And because this number at the bottom, the B value, has negative as its sign, that means the larger number is also going to have a negative. So if these are all pairs, I'm going to put the negative on the side with the larger numbers. So when I add them together, I need to get -5. And if I look here, I see that happens with a +3 and a -8. Now, because A is equal to +1, that means the only thing that we could multiply to get 1x squared would be 1x times 1x. If I had a 2 in front, 2 times 1, that's going to always be more. So, knowing what I know, because that is a 1 in front, the only thing in the front, like I said, has to be an x. And then we use this x part of the x box to figure out that 3 times -8 gives me the -24. So I put +3, which was my first factor here, and -8 back here. And this is my factorization of my quadratic trinomial. It only works when A is equal to 1. Let's go to the next problem. Problem number 6. 3 terms. First off, do I have a greatest common factor? Well, I'm looking at 6, 13, and 5. Smallest number is 5. 5 is not a factor of 6 or 13, and 5 is prime, so the only number left is 1. So no, I don't have a greatest common factor. Then I have 3 terms, so I'm looking at Xbox. Okay, so here's my X. And when I do that, I need to know that A is equal to 6, B is equal to 13, and C is equal to 5. Remember, A, B, and C are always just numbers, no variables. So in the top, we have A times C. 6 times 5 is going to be 30, and the bottom is going to be B, which my B amount is 13. So factors of 30 that add to 13, again, start with your pairs. 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, 5 and 6. And when you write them down, it's pretty obvious to see it's going to be 3 and 10. Now, my A value here is not 1. So I do need to do the X box here. I did the X, now I need to do the box. So up in this box, we have 4 boxes. The very first box is going to be the entire first term, 6x squared. The last box goes with the last term, 5. And for 13x, that involves the 2 factors that we needed to find here on the sides, but they have to add up to 13x. So I have to multiply an x with both of them, making it 3x and 10x. Now I'm looking for the greatest common factor of each row and each column. So let's look at the rows. So you look at this as a new type of problem, 6x squared plus 10x. 6 is your smallest number. 6 is not a factor of 10. So you find the next highest factor of 6, which is 3. 3 is not a factor of 10, but 2 is. So you're going to factor out a 2, and x squared and x to the first. X to the first is going to be the smallest exponent. Next, we look in the second row. We have 3x and 5. So you're looking at 3 and 5. 3 is not a factor of 5. 1 is, and we have to put something in its place. This is not some place where we can leave it, all right? But this has an x, this does not, so I cannot take out an x, and this is a positive 1. Then we look at the column. Let me get another color here. So in the column of 6x squared and 3x, you're looking at 6 and 3. 3 is a factor of 6. X squared and x, the smaller exponent, so that's x. 10x and 5, as I look here, 5 is a factor of 10. So my factorization as I write it down are these 2 factors of 2x plus 1 and 3x plus 5. Okay. Let's go to these last 2 to finish up our notes. 2x squared plus 24x plus 64. GCF, need to look for it first. 2, 24, and 64, those are all even numbers. So yes, we can factor out a 2. And I have x squared plus 12x plus 32. 2 is out front. That's the GCF, that's the factorization. Now I have a new trinomial. So I need to look at X box. A is 1, B is 12, C is 32. So A times C is going to be 32, and B is 12. So factors of 32 that add up to 12. 1 and 32, 2 and 16, 3 doesn't work, 4 and 8, 5, 6 doesn't work. So as I look here, it is 4 and 8. A is equal to 1 here. So yes, we can use these. Don't forget the 2 out in front. So my factorization is 2 times x plus 4, that is a positive 4, and x plus 8. And that is your factorization. Again, only when a equals 1 do you not need or require the box. Okay, so last example that we have here, 9x squared plus 16x minus 4. Look at your coefficients. Smallest number is 4. 4 is not a factor of 9. The next highest factor of 4 would be 2. 2 is not a factor of 9. So I do not have a greatest common factor. So X box is next when you have 3 terms. A equals 9, B equals 16, and C is equal to -4. Put it in my X, A times C, and that's going to be 9 times -4 is 36, and the bottom is B for 16. So factors of 36, -36, are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. That add up to 16. I see here, this is a positive 16, which means my larger numbers are all going to be positive and the smaller numbers are negative. So -2 and 18. All right, A is not equal to 9, so I do need to do the box. So first whole term, 9x squared. Last whole term, -4. Middle 2 on the diagonal with an x is -2x and 18x. So greatest common factor of each row, 9 and 18. Yes, 9 is a factor of 18. X squared and x. Yes, I can factor out an x. -2, which is closest here, and -4. Yes, I can factor out a -2, but there is no x in the second term. Looking at the column, so I'm looking here, 9 and -2. 2 is not a factor of 9. 1 is, and that's going to be 1 with 1x, because this is x to the first. And I have 18x and -4. That's a positive. That's going to be positive. 18, no, start the smaller, sorry. 4 is not a factor of 18, but 2 is. So that's going to be a 2 there. So here are my factors, 9x minus 2 and 1x plus 2. Okay. All right, so now let's go to today's bell work. We are on day 3, and there's a lot of stuff here. Identify the x-intercept, solution, zeros, and roots. Okay, so for number 1, it's not crossing the x-axis, so there is no real solution. And yes, you do need to put no real solution, because there is a solution, it's just not real. So over in the second one, I'm looking at the double root. So my x-intercepts here would be 2 and 2. I'm going to write them both down twice. And then finally over here, my x-intercepts are -4 and 1. Okay, so over here for number 2, it says factor completely. I need to look for a greatest common factor, 3, 13, and 14. I do not have one. So A is equal to 3, B is -13, and C is 14. Put together the x A times C goes at the top. 3 times 14 is going to be 42. And B is negative 13. So factors of 42 that add to give me negative 13. I've got 2 and 21, 3 and 14. That's probably not one you would think of, but you need to go in order and use your calculators. 4 is not, 5 is not, 6 and 7. Because they have to add up to a negative 13, that means at least my larger number is negative, but it has a positive product answer. So a negative times a negative gives me that positive, and adding up to negative 13 is going to be negative 6 and negative 7. So when I do the box, first term goes in the first box, 3x squared. Last term goes in the last box, that's 14. And the middle muddle is negative 6 with an x and negative 7 with an x. Looking at greatest common factor, for 3 and negative 7, 3 is not a factor of 7, so that's going to be 1. And then x, negative 6 and 14. So it is a negative because the negative comes first in the first term. 6 is not a factor of 14, neither is 3, but 2 is. All right, looking at the columns, 3x squared and negative 6x, 3 is going to be the greatest common factor of those terms with 1x here, and negative 7, because in the column that is the first one, is going to be a factor of 14. No greatest common factor, so these are my factors of 1x minus 2 and 3x minus 7. Last example. Factoring by grouping, okay? Factoring by grouping, you want to divide these into 2 and 2, and it's a little bit tricky. We could change this into a trinomial, but because we can simplify 2x minus 5x, but factor by grouping is a little bit better. So I'm looking for the greatest common factor for negative 2x squared and 2 because this is your first term. Yes, you have to factor out that negative. And I also have an x that I can factor out. Okay? Over in the second one, I have negative 5 and minus 10. So factor out the negative 5. And let's then pull these greatest common factors out in front. Negative 2x times, what do I have left? Negative 2 divided by negative 2 cancels. X squared divided by x is going to be x to the first, or just x. 2 divided by negative 2 is going to be a minus 1. So 2x divided by negative 2x. These all simplify out, but a positive divided by a negative is negative 1. Looking at my second half, this right here. So we factor out in front that negative 5, and negative 5 divided by negative 5 leaves me with this x. And, ooh, why didn't this work? Negative 10 divided by negative 5. That would be a plus 2. Well, isn't that special? That one did not work. So that's a bust. We'll stop on that one and I'll fix that another day. All right, so now let's go back to the notes that we would have for today. Ooh. Notes for today. And we're looking at right here. Okay. 12.4, solving quadratic equations by factoring. This is why we are coming back to factoring, because we're going to be solving them. So the first thing we're going to learn about is the square root property, okay? To solve a quadratic equation in the form of something squared equals n, you take the square root of both sides, okay? So you have to have the whatever squared on the left, I guess it could be on the right, and the other value on the other side of the equation, okay? If x squared is equal to n, and you take the square root, remember, x is then equal to plus or minus the square root of n, because negative times negative gives you positive, and the positive times positive. So x squared equals 49. That's the example they're showing here. If you take the square root, the square root of x squared, these essentially cancel out. And you don't have to write all that, but it does give you just x, which is equal to the square root plus or minus the square root of 49. And the square root of 49 is 7, so x is equal to plus or minus 7. Okay, so let's take a look at these examples. And here we go. Square root property. So I have this quantity squared equals 25. So I am going to take the square root of both sides. When I take the square root, this 2 on the inside and this 2 of the square root cancel out, and I am left with x plus 7 equals the square root of 25, which is plus or minus 5. Now, I need to get x by itself. So I need to move this 7 that's being added. I will subtract 7. So I'm going to subtract 7 over here. 7's cancel out. So x is equal to, I have two versions. I can say positive 5 minus 7, and x is equal to negative 5 minus 7. So 5 minus 7 gives me negative 2. Negative 5 minus 7 equals negative 12. So my answer is x is equal to negative 2 and x is equal to negative 12. All right. So letter B. It's almost a song. Letter B, letter B. Okay. So here I need to get this x squared by itself. Okay. So I can have and square root both sides. So I'm going to divide by 3 here. Divide by 3. 3's cancel out. And I get x squared is equal to 9. So now I have that x squared by itself. Take the square root. Take the square root. So here, x is equal to plus or minus 3. Because the square root of 9 is 3, but we also know that a negative 3 times a negative 3 gives us a positive 9. So these are my two solutions for this quadratic equation. Okay. Example 2, solve an equation by using the square root property. Okay. So I have this entity squared equals 21. It is by itself, so take the square root, take the square root. So I will get y plus 5 is equal to plus or minus the square root of 21. 21 does not have any perfect squares in it. If you remember, we took 21, and if we would do like our cake, okay, we can only divide by prime numbers, 2, 3, 5, 7. All right, so it's not even. It is divisible by 3. That gives me 7. 7 is divisible by 7. That gives me 1. So my only factors there are 3 and 7. I don't have any pairs. But I need to get y by itself. So I need to subtract 5 here. Subtract 5 here. 5's cancel out. Y is equal to, and because we have that whole thing there, we usually put the regular number, the integer, whatever that is, -5 plus or minus the square root of 21. So that would be y equals -5 plus the square root of 21, and y equals -5, well, if I can write, -5 minus the square root of 21. Okay? All right. Last one. We have quantity x minus 2 squared. That whole thing is squared. Take the square root. Take the square root. So the 2 is gone, and I get x minus 2 equals square root of 16 is plus or minus 4. This is being subtracted. I want to solve for x. So let's add 2, add 2. So x is equal to positive 4 plus 2, which x is equal to 6 then. And in the second one, x is equal to -4 plus 2. So x is equal to -2. So together, we get x equals 6 and x equals -2. Okay. All right. I'm just looking here at what I have. I think I will stop there for today, and we'll go on with the rest of this on Friday, okay? See if you can use that. Homework number 1 is due today. If you're not ready and it's not complete, don't turn it in. Try to turn it in Friday or even next Tuesday or Wednesday, okay? Better to turn it in with what you understand and what you can do than turning it in and leaving some blank. All right. Thank you so much for listening and watching the notes. Hope you have a great rest of the day, and I will see you on Friday. Bye-bye.